The first part of Mod 1B deals with the rules of exponents. I have given each of the rules of exponents along with an example, and then we are going to work through some other examples as we go forward. The product rule says that if you are multiplying two bases and they have exponents on them, x to the a times x to the b, your answer is x to the a plus b. So using numbers, if you had x to the 5th times x to the 8th, that would equal x to the 5 plus 8, which is x to the 13th. The quotient rule says if you are dividing your two bases and they each have exponents, that you subtract the exponents. Take the exponent of the top minus the exponent of the bottom. So if you were doing x to the 10th divided by x to the 4th, you would do x to the 10 minus 4, which is x to the 6th. If you are raising an item that already has an exponent on it to another exponent, so you have x to the a that you are raising to the b, you multiply those exponents and it becomes x to the a times b. So x to the 4th being raised to the 8th becomes x to the 4 times 8, which is x to the 32. If you have two bases being raised to an exponent, each of those bases is being raised to that exponent. It's similar to the idea of the distributive property. So if you have x times y and both of those are being raised to the a power, then that becomes x to the a times y to the a. Numerically, if you have xy being raised to the 5th, then that would become x to the 5th, y to the 5th. This same concept holds true if you have two bases that are being divided, but both of those are being raised to a power. If you have x divided by y that's being raised to the a power, that becomes x to the a over y to the a. Using numbers, if you had x over y being raised to the 4th, that becomes x to the 4th, y to the 4th. It is very important to remember that x to the 0, it does not matter what the base is. If you have a 0 power, that answer is 1. If you have a negative exponent, if you have x to the negative a, to make that into a positive exponent, you put it in the other position of the fraction. If you think about x to the negative a, that could be written as x to the negative a over 1. You move the item that has the negative exponent to the opposite position of the fraction. So that would become 1 over x to the a. On the other hand, if you had 1 over x to the negative a and you wanted to make it positive, you would move it up to the top and make it x to the positive a. So numerical examples of this, x to the negative 2 is the same thing as 1 over x squared. 1 over x to the negative 6 is the same thing as x to the positive 6. The last rule, if you have fractional exponents, the numerator in that fraction is the power, and the denominator tells you what root it is. So x to the a over b is x to the a inside the b root. Or you take the b root of x and raise it to the a. Numerically, if I have x to the 3/4, that means I'm doing the 4th root and the power on x is 3. Or it also means doing the 4th root of x and then raising it to the third power. In example 1, our instructions tell us to rewrite the expression without using negative exponents. For part A, our expression says negative 3m to the negative 2. When you are moving an item to make it a positive exponent, you move only the item that has the exponent on it. So in this case on A, we're going to leave the negative 3 where it is and move only the variable m, and then by putting it in the opposite position, it now becomes positive. On B, we have 1 over 2n to the negative 5. We're going to leave the 1 where it is. The negative exponent is on the n. So the 2 will stay in the bottom, and the n will move to the opposite position in the fraction. So because it was in the bottom, it goes to the top. And then when it does that, it changes the sign of the power. So it becomes 1n to the 5th over 2. The 1 is not necessary, so you could just write n to the 5th over 2. On example 2, we are asked to evaluate the expression. We have a fraction that's being raised to a negative power. In order to make that into a positive power, you write the reciprocal of the fraction. This then changes the power to a positive number. So 8/5 to the negative 1 becomes 5/8 to the positive 1. But that just equals 5/8 because anything to the first power is itself. On B, we have 4 over 7 to the negative 2. So the first thing we're going to do is write the reciprocal, make it 7 over 4, and then change the sign of our power to positive. Now we're going to use our rule that says when we have a fraction being raised to the power, you take each part to the power. 7 to the second over 4 to the second gives us 49 over 16. Example 3 says to simplify the expression. Each of these problems has common bases that are being multiplied. So each of these problems is using the product rule. On A, where we have y squared times y to the negative 8, the product rule means we would do y to the 2 plus negative 8. But that equals y to the negative 6. We generally write our answers with positive exponents, so this would become 1 over y to the positive 6. On B, where we have u to the negative 4 times u to the 6 times u to the 3, this would become u to the negative 4 plus 6 plus 3. And if you add those numbers up, you are going to get u to the 5th. Since that is positive, you can just leave it alone. On C, we have x to the negative 5 times x squared times x to the negative 4. So we're going to have x to the negative 5 plus 2 plus negative 4. Do that addition, you will get x to the negative 7. Again, we generally write answers with positive exponents, so this would become 1 over x to the positive 7. On D, we are continuing with the idea of simplifying our expression. But when you look at this expression, it's kind of complicated looking. We have 6x to the negative 3 times 2u to the negative 6, w to the negative 2, w x to the 9th, times 3u to the 8th. One thing that will help us a lot is if we group our like items together. So I'm going to start by putting the numbers together because we are allowed in multiplication to reorder the multiplication, and the answer will still be the same. For example, 3 times 5 equals 5 times 3. You can change the order, you get the same answer. So I'm going to group the numbers together. Have 6 times 2 times 3. The first letter we run into is an x, so I'm going to look for all the x's. I have x to the negative 3, and I have x to a positive 9. The next letter that I see is a u. So I've got u to the negative 6 times u to the 8th. And then the other letter that we have is w to the negative 2 and w. Now that I have everything so that they are like items next to each other, it's easier to see how to work this problem. 6 times 2 times 3, 12 times 3 is going to be 36. On the x's, when we add negative 3 plus 9, we get x to the positive 6. On the u's, negative 6 plus 8 gives us positive 2. And on the w's, negative 2 plus 1 gives us negative 1. We don't want to have any negative exponents in our answer, so the only thing that's going to move is the w. Everything else is going to stay in the numerator, 36x to the 6th, u squared, and then we're going to move w to the 1st to the bottom. You don't have to write that 1 on the w, you can just write it as w, so you could just write 36x to the 6th u squared over w. Example E is very much like example D. I'm going to start by grouping the like items next to each other. So we're going to start with the numbers 2 times 7 times 3. The first letter that I run into is a W, so I'm going to find all the W's. I have W to the 9th times, on the end we have a W squared. The next letter that I see is a V, so I'm going to have V to the negative 1 times V to the positive 1. And then with X's, I have X to the 9th times X to the negative 6. Just by putting the like items next to each other, it makes it so much easier to see what you need to do. For the numbers, 14 times 3 gives me 42. On the W's, 9 plus 2 gives me W to the 11. On the V's, negative 1 plus 1 gives me V to the 0. On the X's, 9 plus negative 6 gives me 3. What you have to remember is that anything raised to the 0 power is a 1. So we had 42 W to the 11 times 1 times X to the 3rd. Well, that 1 is unnecessary to have in our answer, so we're going to just write it as 42 W to the 11th X to the 3rd. Examples F and G are both using the quotient rule. We have an expression of y to the 8th over y to the negative 3 on example F. The quotient rule tells us to leave the base the same and take the power of the numerator minus the power of the denominator. So we would have 8 minus negative 3. But that becomes 8 plus 3, so our final answer would be y to the 11th. On example G, same idea. We have the same bases, so we need to subtract our powers. The base stays z. We take the numerator of negative 5 minus the denominator of negative 3. Well, this will become z to the negative 2. We don't leave negative powers in our answer, so we'll have 1 over z to the positive 2. Examples H and I are both using the power to a power rule. If you have an item being raised to a power, and then that item's also being raised to a power, the rule is that you multiply those powers. So on H, where we have u to the negative 3 being raised to the negative 6, this equals u to the negative 3 times negative 6. Well, that becomes u to the positive 18. On I, y cubed being raised to the negative 4 would become y to the 3 times negative 4, which would become y to the negative 12. Make your power positive, so become 1 over y to the positive 12. On items J, K, and L, we are still using the power to the power idea, but we are using it on several items within a set of parentheses. So on J, when we have 2x squared over y to the negative 3, and that whole thing is being raised to the negative 5, we have to spread that negative 5 power through to each item. So it becomes 2 to the negative 5. And remember, you're multiplying these powers, so it becomes x to the negative 10. And then on the denominator, when you multiply those powers, it would become y to the positive 15. So to complete this and make your powers positive, both of the items in the numerator need to move to the denominator. When that happens, you have to hold the place of the numerator with a 1. We're now going to have 2 to the positive 5, x to the positive 10, y to the 15th in the denominator. We need to clean that up by doing 2 to the 5th. 2 to the 5th is 32, and then we have x to the 10th, y to the 15th. On K, the same idea applies. We have to raise each item within the parentheses to that second power that's on the outside of the parentheses. So we start out by doing negative 4 and raising it to the second power. Y to the 6th, raised to the second power, multiply, you get 12. Z to the negative 4, raised to the second power, you multiply and get negative 8. Negative 4 squared is negative 4 times negative 4, which is positive 16, y to the 12th, z to the negative 8. To clean it up and make our powers positive, we'll have 16 y to the 12th over z to the positive 8. For item L, when we have c to the negative 4th over 2b to the 3rd being raised to the negative 5, same idea. We are going to raise each item to that negative 5. On the numerator, c negative 4 times negative 5 gives me positive 20 over. We need to do 2 to the negative 5. b to the 3rd being raised to the negative 5 is going to be b to the negative 15. We need to take both of those items from the denominator and push them to the numerator. So it becomes 2 to the positive 5, b to the positive 15. The c is going to stay in the numerator because it was already positive. Now just finish it out by raising your 2 to the 5th. That's 32. B to the 15th, C to the 20th.